For Newton's laws of motion, we have actually talked about that maybe in middle school and maybe in elementary school. Basic Newton's laws of motion is anything that has to do with the motion and the force of the universe. The reason you are able to jump up and not fly away, the reason you're able to not be pushed to the floor because of gravity, the reason why when you keep going, you can actually stop. That's all Newton's laws of motion. It's all around us. Now, there's three main types of laws of Newton's laws of motion: the first law, the second law, and the third law. And the first law, Rosalinda already shared with us that, an object in motion will stay in motion and an object at rest will stay at rest unless another force comes through it and actually opposes it. This is also known as the law of inertia. Now, inertia is a fancy term. It basically just means the resistance to change. The resistance to change. That means something that does not want to change direction. It does not want to change velocity. It doesn't want to change at all. It wants to keep going. So if you have something that's very, very big, like a big boulder, and that boulder keeps rolling down the hill forever, it has a very high inertia because it does not want to move at all. It doesn't want to change direction. It's going to keep going down the hill. That's the law of inertia. The second law, and we know that Emily was able to share with us, is basically force equals mass times acceleration, right? This is the equation law. This is the only law that has an equation in theory. And it's force equals mass times acceleration. Force is measured in units of newtons, that big capital N. Mass is measured in kilograms. And acceleration is measured, like you guys already know, meters per second per second. Okay. Now this works in a way, if you have two boxes, if one box has a higher mass, like weighs more, that means it's going to take more force for you to push that box, as opposed to a box that has less mass, that's much lighter. It's not going to take as much force for you to push it. Okay. The more mass, the more force you need to push it. And last but not least, we have the third law of motion that Lourdes was able to describe. For every action, there's an equal and opposite reaction, and this is called the cause and effect law. The cause and effect law. And that basically means for every action, there's an equal and opposite reaction. If you guys have like those heavy doors on your house, when you push that door will automatically come back and push you back because it's so heavy. And it's a good way for it to always stay closed. Another example is if you jump up, gravity is going to use the same force to push you back down. So the reason you don't jump on forever is when you jump off, gravity is going to give you that same exact reaction, the same force pushing you down, so your feet can touch the floor again. Awesome. And then what all these three laws have in common, it's all about force. Nope, it's about the force of, it's not about Star Wars force. It's about this type of force. It's all about force for this one. In case you want to know what force is a push or a pull from an object. So whether you push or you pull, that's force. So basically, anytime an object is moving, when you're walking, when a car is driving, when you're pushing a box, when it's moving, that's all force. All of that is force. Force is measured in newtons. Kind of like Isaac Newton. Isaac Newton was the man who discovered gravity and gave way to the three laws of motion that we still use today. Here's the fancy way of putting it. Kilograms times meters per second squared. But that's a little bit too confusing, so we're going to stick with newtons, which is N. The unit for N is newtons. Now, there's many types of forces, but the main ones we're going to focus on are normal force, frictional force, applied force, and gravitational force. These are the four main ones we're going to talk about. We'll talk about more about it next week, but kind of want to give you a little introduction on it. Okay, so very quick recap. The first law of motion, an object in motion or at rest will stay at the same place or the same state unless an unbalanced force acts on it unless something comes up and opposes that force. That's Newton's first law of motion, also known as the law of inertia. The second law is force equals mass times acceleration. It's our equation law. Basically means the higher the mass, the more force you need to push it. The lower the mass, the less force you need to push it, which will result in either a high or a low acceleration. And Newton's third law of motion is the cause and effect law. For every action, there's an equal and opposite reaction. All three of these laws have force in common. Force is a push or a pull from an object, and it's measured in units of newtons, capital N. There are many types of forces, but the main ones we're going to focus on are normal, frictional, applied, and gravitational force. Okay, so an object will stay in its current state unless acted by an unbalanced force. The ones who were able to answer, the majority of you, all of you actually chose Newton's first law, which is correct. This is indeed Newton's first law. So you click on it, change the color to orange. Good job. Even if you didn't do the color coordination, it's okay, as long as you're able to understand which one's which. So yeah, everyone did choose Newton's third law of motion. This is for every action is equal and opposite reaction. Good job. Which means force equals mass times acceleration. This one is Newton's second law of motion. Remember, the second law is the only one that has an equation. Okay, good job. Okay, awesome.